So this is chapter 5.1, or this is section 5.1 from chapter 5. We just did chapter 3, which is about graphing. We're skipping chapter 4, and we're going straight to chapter 5 to get us ready for intermediate algebra. So this is intro to polynomials. In this section, we're just basically going to be looking at what is a polynomial, how do we describe it, how we talk about it. And that's about it for this particular lesson. All right, basic terms. So I'm going to basically go through a list of terms. Then I'm going to go through and break all these down into and give a little more information about each of these after I give a basic definition of it at the beginning. A polynomial is a collection of letters and numbers with adding or subtracting between the parts. So, for example, if we look at here, we have 3x squared, got some letters, got some numbers, plus some adding, 7x, a letter and a number, minus 5. So we got some letters, we got some numbers, we got some adding, subtracting in between. We also have 4x minus 2, and some letters and numbers, and some things in between. And we're going to talk about how to split those into parts so that we don't kind of smush everything together and just kind of push everything in a way that doesn't really make sense. So we're going to try to look at it and try to split it into reasonable parts. So let's look at 4x. So the way we're going to do that is we're going to say term. A term is one part of a polynomial. So for example, 4x minus 2, so I'll say it again, 4x minus 2 has two terms, are parts. The first term, the first part is 4x. The second term, the second part is minus 2, or negative 2 in this case. All right, and we're going to be doing a little bit of, so the minus and the negative are going to kind of flow together to a certain extent. So you're going to have to get used to the idea of saying, okay, is that a minus or is it negative? Well, they're kind of similar when they get involved in operations. So we're going to kind of think of minus and negative almost interchangeably in a lot of ways when we start talking about them. All right, so 3x squared plus 7x minus 5 is split into three parts. The first part is 3x squared. The second part is plus 7x. The last part is a minus 5, or a negative 5. There are three parts. 1, 2, 3. See how I'm splitting it up? I'm just basically going through 1, 2, 3. Now, the way we basically figure that out is we work a lot of problems and we get to the point where we can kind of visualize how we're splitting things up. If I was working this on a board, I'd put lines in between like that and that. That's how I'd put lines in between. All right. But a term is just one part of a polynomial. All right, next slide. Let's get some more basic terms. A variable. A variable is a letter that represents a numerical value. So in other words, so far we use x and y. We were able to kind of plug in x's to get y's, and x could be any number we want it to be, and we could plug in x is 0, and x is 1, and x is 2, and y could be different numbers too, and x and y are basically just letters that stand for numbers. They basically stand for stuff. All right, next exponent are a power. It goes above a letter or another number. So for example, this 2 is my exponent, this 5 is my exponent. In a lot of ways, one of the things in math you have to be able to do is recognize what something is by its location. So if I look, this 2 is located above the x. That tells me it's an exponent or a power. This 5 is located above the 4. That tells me it's an exponent or a power. I know that because of where it's located. All right. A degree is the largest power of a polynomial. We just said, well, this is a power. So we're going to come back and we're going to kind of describe what that means in a minute. All right. A polynomial is a very common thing in mathematics. So if you see this is a polynomial, negative 2x plus 7. This is a polynomial, x squared plus 3x. This is a polynomial, 4x squared minus x plus 6. And this is a polynomial, 2x cubed minus 5x squared plus x plus 3 is also a polynomial. These are all polynomials. So you can see that they can look very different from each other and all be polynomials. Doesn't have an equal sign, and it's made of letters and numbers. So essentially, lots of things are polynomials. All right, and again, if we divide a polynomial into parts, they're called terms. So if I was to take this first polynomial right here and split this into its parts, it would split right in the middle, right here, and it would be negative 2x would be the first term, and plus 7, or positive 7, would be the second term. If I was to split this last one, for example, into its parts, I would have 1, 2x cubed, 2, negative 5x squared, 3 plus x, and 4 plus 3 terms. There are 4 parts to this polynomial. 1, 2, 3, 4. So again, we just kind of have to work on these a little bit to where we can just kind of visually see, oh, those are the parts. So it's just kind of like it's just kind of like anything. We have to work on it. All right. Now, you can split a polynomial into terms. So if I can split a polynomial, I can split it into terms. I can split a term into more parts. And the parts of a term, it can usually be divided into 3 parts. The first part is called a coefficient. Coefficient is a fancy word that means a number that goes right before a letter, also known as a variable. So a number that goes right before a variable. So here's your variable x. Remember, x is a letter, it's a variable. What number goes right before it? Like right before it in order? Well, it's got to be this one. This is your coefficient. It's just a number. Your coefficient is 6. So a term has a coefficient, which is 6, a variable, which is x, and a power or exponent. So remember, the exponent is just it just sort of sits right above the letter. So instead of being next to it, it just sort of sits right above, right on top of it, sort of. Well, in this case, it's 3. So our exponent is 3. So our coefficient, our variable, and our exponent, our power, is right there. Coefficient is 6. Our variable is x. Our exponent is 3. So let's keep talking about these. All right. Coefficient. Let's talk some more about coefficients. So let's say I have a polynomial. I have 4x to the 3 plus 2x to the 2 minus 3x plus 1. So I have 4 terms in my polynomial. 1, 2, 3, 4. And the coefficients, the numbers that go right before the letters are 4, 2, or in this case, a plus 2, a 3, which is a minus 3. And we also have this 1 over here. But for some reason, it's not being called a coefficient. We're calling it something different. Like these are called coefficients, and this isn't being called a coefficient. So why is that? Well, think about the definition of a coefficient. The definition of a coefficient is a number that goes right before a variable, i.e. a letter. So let's look at this 1. Is this 1 right before a letter? No, it is all by itself. Because it isn't next to a letter, it isn't a coefficient, because a coefficient has to be next to a letter. It's not next to a letter, it's not a coefficient. However, let's look at these right here. I got a 4, 4 is next to a letter, 2 is next to a letter, and -3 is next to a letter. So that means that 4, 2, and -3 are your coefficients. Again, 1 is not next to a letter. It's not a coefficient. It has to be next to a letter to be a coefficient. That is the definition of a coefficient. All right. Second example. For the polynomial 4x y to the 2 plus 3x minus 5, the coefficients are 4 and 3. Now notice that we didn't include -5. But there's a reason why we didn't include -5. Because -5 isn't next to a letter x, so it isn't a coefficient. Also notice that there are 3 terms. 1, 2, 3. So the coefficients in this case are the 4 and the 3 because they're right before a letter. Now, let's talk about some more about exponents, because remember, a term is composed of a coefficient, a variable, and an exponent. So let's talk some more about exponents. What is an exponent? This is going to be really important. An exponent tells you to multiply a number by itself a certain number of times. So what does that mean? Okay, let's just see what it means. So I have 2 times 2 times 2 times 2 times 2. I have 5 2's, all multiplied by each other. It appears 5 times, therefore I have a 2 multiplied by itself 5 times, that's 2 to the 5th. If I look over here and say, okay, what does this exponent do? Well, I have a 6 times a 6 times a 6, which is 216. And because I have this, it's multiplied how many times? 1, 2, 3. It's multiplied 3 times. There are 3 of those 6's, right? So it's 6 raised to the 3rd power. The exponent tells you how many times to multiply it. All right, so again to recap, a term is one part of a polynomial. So if I take a polynomial and I split it into parts, I hack it into parts like this, just go down like this, 1 part, 2 parts, 3 parts, 4 parts, however many parts there are, and I hack it into parts, then a term is a part of that polynomial. So if we're gonna go back and recap, let's go back to this one right here. If I took this into parts, 1, 2, 3, 4. That's what term. That's 4 terms. 1, 2, 3, 4 terms. All right. A term can usually be divided into 3 parts. The 3 parts of a term. So a polynomial gets split into terms. A term gets split into other parts. And the parts are called a coefficient, a variable, and an exponent. All right. Now let's get into a special rule we have. In mathematics, because we're not English majors, we don't often like to write a whole bunch of stuff. So we use a lot of shorthand. In fact, sometimes we even just leave things off because when we know something, we don't have to write it out. So one of the things that we just kind of know if we know math is if we don't put something in front of an x, well, it's automatically a 1. Or if we don't raise an x to a power, it's automatically a 1. We just know that because that's just something that, if you do a lot of math, you get told that over and over again. So there's something that I'm going to call I'm not sure who else calls it this. I'm going to call it the invisible one. So, for example, let's look at this example here. I have an expression, x plus 2. It has two terms. There are two terms in this expression. The first term is the x. So let's take a look at this x. This plus 2 not interesting to me, but this x is really interesting. The first term looks like it only has one thing going on, but it's got three things going on, just like most terms. The three things it has going on are it has a coefficient, it has a variable, and it has a power. But you say, well, where are the coefficient, variable, and power? Well, here where they are. We can take that x and rewrite it as a 1, so put a 1 in front because there's an invisible 1 in front of the x. And up top, we have an invisible 1 raised to the power. So we've got a 1 out in front and a 1 up top. We didn't write either one of those because in math, we don't have to. We just kind of go, well, we know it's there. We don't have to write it. You know it's there. Come on. That's kind of the basic idea. But until you get to the point where you're like, I definitely know the 1 is there, even though I can't see it, it's important that we write it out. So when we have an x, even though we don't see them, there is a 1 in front of the x and a 1 on top of the x. So the 1 in the front and the 1 as an exponent are both unwritten. They basically are our invisible ones. Let me show you where that comes into play. Example number 1. The term 7x has three parts. It has a coefficient, it has a variable, and it has a power. Now you say, well, I don't see a power. You don't see a power. That's where the invisible 1 comes into play. So let's go through it. Let's go through three parts. Part number 1, coefficient. Coefficient is a number out in front, 7. The coefficient is 7. Variable, it's the letter we have. What's the letter in this case? X. Power, well, we don't have a power. Yes, we do. The power is a 1. It's invisible. We don't write it out. You can't see it, but there it is. The power is 1. It's very important that you understand that if nothing is written up here, the power is not 0. The power is 1. So the exponent in this case is a 1, not a 0. It is a 1, not a 0. The exponent in this case is a 1. So we have a coefficient of 7, a variable of x, and a power of 1. Now, let's go to our second example of this. In this example, we have a term, y to the 9. It's got three parts. What's the first part? Well, with the coefficient. Yeah, but I don't see a number next to the letter, or at least not in front of the letter. That's because we have an invisible 1. The 1 is invisible. We're not going to write it. It's unwritten. When you do enough math, you just know it's there. You just assume it's there. But there it is. It's an invisible 1. But the coefficient in this case is a 1. The variable is the letter y, because that y is a letter. The variable is a letter. And the power in this case is 9. So we do have a coefficient. It's not 0, it's 1. All right. We'll do 3 examples, and I'll walk you through these 3. The first one, the first and third one are pretty straightforward. I'm not going to spend too much time on those. All right. Identify the coefficient, the variable, and the power, or the exponent. I keep saying power. You can say exponent. It's the same thing. All right, example number 1. Identify the coefficient, variable, and power for the term 5x to the 7. All right, the coefficient is 5. The variable is x. the power is 7. I don't think I need to go over that too much. It sort of lines up. If you kind of see 5x7, cool. I'm gonna skip down to the bottom. Identify the coefficient, variable, and power for the term -8y to the 6. Well, the coefficient is -8, the variable is y, and the power is 6. Okay, so again, not super complicated. Let's go to example 2. So this is where it gets trickier. We want to identify the coefficient, the variable, and the power for the term 4m. So what's the variable? The variable is m. It's the letter. A variable is a letter. What is the coefficient? What is the number that goes before the letter? Well, it's 4. There's a 4 that comes before the m, or it's right in front of the m. So the coefficient is 4. What is the power? Well, we don't see a power, and if we don't see a power, we know that there is up there an invisible 1. So the power is 1. Okay. There's a reason why we did that. There are 2 ways to classify a polynomial. In other words, name it, essentially. How you name a polynomial. If you want to describe a polynomial to me, how would you describe it? There are 2 ways to do that. Number 1, number of terms. How many terms are there? Number 2, the largest power are what's called the degree of a polynomial. And I'll go through these are charts that kind of walk you through it, but I'll go over these charts in a minute. All right. The first way to be classified polynomials is by the number of terms. How many parts does it have? So let's go through this chart, and then I'll go through the examples. I have a 2x. Now remember, a term, we're not going to split that 2x into a 2x, like split it apart. We're going to say 2x is one term. 2x is one term because the 2 and the x are connected to each other. So if it only has one term, it's called a monomial. All right. Think of it like if you have Monopoly, there's one winner because they are the one who basically owns, basically has money. So basically the way that you win Monopoly is by being the last person to have money. So one person wins the game because they're the one person who has money. Mono means one. Monomial. So it's just one term. So if I see one term, it's a monomial. But let's say I have not just one term, but 2 terms. I have 2x plus 3y. Well, what has 2 wheels? A bicycle has 2 wheels. If a person works 2 jobs, they're said to be bivocational. Bi means 2, like a bicycle has 2 wheels. So binomial composed of 2 terms. All right. Then let's say we have 3 terms. I have 2x squared plus 3x plus 5. I've got 1, 2, 3 terms, this one, that one, and that one. Well, what has 3 sides? Well, a triangle has 3 sides, and a tripod has 3 legs. So a triangle has 3 sides, and a tripod has 3 legs, so trinomial must mean 3. Polynomial. So sometimes they have more than 3 terms, in which case we don't really have a name for it. We could make up a name, but we just chose not to because we just didn't feel like it. So if it has more than 3 terms, we don't call it anything. We just say polynomial. So for example, 3x cubed, 2x squared, minus 6, plus 2, that's 1, 2, 3, 4 terms. And so we could call it a quadrinomial, I guess, but we don't. We just call it a polynomial. We just say, what is it? It's a polynomial. We could make a name up for it if we wanted to. We chose not to. So 1 term is called a monomial. 2 terms is called a binomial. 3 terms is called a trinomial. And if it's more than 3 terms, we use the term polynomial. All right, let's get to our examples. Example, 5x cubed minus 7x has how many terms? All right, we got 5x cubed and minus 7x. That's 2 different terms. It's a binomial because it has 2 terms. 6x to the 8 minus 9x to the 2 plus 7x has 3 terms because we got this term, that term, and this term. So since it has 3 terms, we call it a trinomial. Like a triangle has 3 sides. And then last but not least, well, not really last but not least, but 7y has only 1 term. It's all by itself, just sitting there, just being all by itself with no friends. So it is a monomial. Like in Monopoly, there is 1 winner. Or, yeah. And so last but not least, we've got 7y to the 5th minus 6y to the 3rd plus 4y squared plus 9y. So 1, 2, 3, 4. I've got 4 things. So what do I call something if I have more than 3 things? Well, I don't really give it a name. I just call it a polynomial. I guess we could come up with a name, but we didn't. All right. Now, we can also do it by degree. So this is the second part. We ask ourselves, what is the highest power? So let's look at what we got going on here. I've got 3x squared, or 3x to the 2, plus 5x minus 7. So I look at all the powers. Where are the powers going to be located? Well, they're going to be little tiny numbers above the letters. In this case, the power here is on the 2. That's the only power I have. Therefore, it has a degree of 2, since the largest exponent is 2. Second example. 5x to the 4th minus 7x cubed plus 2x plus 1 has 2 exponents, okay? We got a 4 up top and a 3 up top. Now, we only care about the largest number, the largest exponent. 3 is smaller than 4. 4 is bigger than 3. Therefore, 4 is the largest. Therefore, the degree of the polynomial is the largest exponent. In this case, it's 4. All right. So just a little note, in general, we don't add all the exponents together. One of the biggest mistakes that students make is they try to add all the exponents together. We don't add all the exponents together. There are cases where we do. I'm not going to get into those cases. Well, Not right now. But most of the time, all we do is pick the biggest number. So in this case, 4 is the biggest. All we care about is the 4. Pick the 4, that's what we go with. This is a chart that will kind of goes through and says if it's first degree, it's linear. If it's second degree, it's quadratic. If it's third degree, it's cubic. Fourth and fifth, so on and so forth. We'll do an example. Okay. Question 1. How many terms does the polynomial have? Question number 2. What is the largest exponent, i.e., what is the degree? First example, we want to classify the polynomial 4x to the 5 minus 7x. So, number 1, how many terms are there? There are 2 terms. So, if there are 2 terms, we call that a binomial. The largest exponent in this case is a 5. Look at it. If you look at it, we see, oh, here's this 5 right here as an exponent. So what's that called? Well, let me look it up. If I have a degree of 5, what would I name it? I would name it a quintic. I'm gonna call it a quintic polynomial. So let's put it all together. It's a binomial and it's quintic. So that makes it a quintic binomial. Let's do another one. Again, 2 questions. How many terms does it have? What is the largest exponent? So, how many terms does it have? 1, 2, 3. It's got 3 terms, 3 parts essentially. It's a trinomial. Where I get that from? Over here. Trinomial consists of 3 terms. Trinomial. All right. Then we go, what is the highest, what's the largest exponent or the highest power? So in this case, the largest exponent is a 3 because we have a 3 and a 2, it's got to be a 3. All right. If it has a degree of 3, what do we call it? We go back here. If it has a degree of 3, we call it cubic. So what we have is a trinomial that is cubic. What we have is a cubic trinomial. All right, we'll do it again. I've got 9x to the 4th. There's only one term. 9x to the 4th is all 1 unit. So there's only one term, so we call it a monomial. Then we look at and see what is the largest exponent. The largest exponent is 4. That's the only exponent we have in this. So what do you call it when you have an exponent of 4? And we go to our chart and we say if the largest degree is 4, then that means that what we call it is quartic. So the largest exponent is 4. It makes it quartic. It's only one term, so it's monomial. It's a quartic monomial. Last practice example. 9x to the 7 plus 8x minus 1. There are 3 terms, therefore we call it a trinomial. The largest exponent in this case is this 7. Now, what do we call something if it has a degree of 7? So let's look and see on our chart. We don't have that on our chart. This is the chart that tells us what to do if you have a degree in 7, to have a degree of something. So what that means is we don't have a name for it. All we do is call it a polynomial. So to summarize, we are going to talk about polynomials in this chapter. So we have discussed different words we need to know. Things like terms, things like degree, exponent / power, polynomial, coefficient, and variable. We saw 4 examples of polynomials. They look very different from each other, but they all have the same thing in common, which is they were composed of letters and numbers. Letters and numbers. And there's no equal sign. So that tells us it's a polynomial. And to finish up the summary, monomials have 1 term, binomials have 2 terms, trinomials have 3 terms, and polynomials are anything that's 4 or greater. When we're classifying polynomials by degree, we can count the highest power. So let me do 1. This is a 4. The 4 tells me that the highest power is a quartic, and I'd have to check a little bit, but the 4th is a quartic function, and so basically now I can describe polynomials in a mathematical way, and then when we start doing other stuff, you'll know kind of what the terminology is, so we can move a little faster on those. All right, that's it.